Mass is energy. This is what Einstein's famous E=mc² means. In the atoms which make up matter, about 99% of mass comes from the kinetic energy of quarks and the binding energy between them. All this energy forms a significant amount of the mass we encounter in everyday life. But there's that 1%, without which the universe wouldn't exist. It would be impossible for atoms to form, and everything would, quite literally, fall apart. It comes from the rest masses of quarks and electrons. QFT is pretty complex, but in its simplest form, it tells us that these particles are excitations of fields which fill the whole universe. The fields are like lakes, where the particles are like the ripples caused by adding energy. Despite its accuracy, this theory had one flaw. It thought all particles were massless. Sure, some are, but most definitely are not. The solution? A new field that interacts with specific massless particles, giving them mass. The Higgs field. The more a particle interacts with the field, the greater its mass and its inertia. Despite this, the Higgs field itself doesn't slow particles down. There's no friction. If there was, nothing with mass could move. But for the Higgs field to always interact with particles, it must always be on. And it is. While most fields have a bowl-shaped energy graph and settle at a zero value, the Higgs settles at a non-zero value. But doing this breaks symmetry. Without symmetry, physics is inconsistent and can sometimes even fail. The workaround is a Mexican hat energy graph. Just like the bowl, we can rotate it with no effect, so it still has rotational symmetry, and the laws of physics remain symmetric. Now, we can break symmetry without the consequences, and the new minimum energy has a non-zero value, allowing the field to interact with particles. But how do we prove the existence of an invisible field? The Higgs field can be excited to form the Higgs boson, an extremely heavy, unstable particle with an extremely short lifespan. But this doesn't stop scientists at CERN from colliding high-speed protons together to detect it. After millions of tests, we know the Higgs boson exists. The Higgs field is real, and we finally know why stuff has mass.